So the main conclusions, that we have experience with this tool that we have been using for 10 years now in different regions. It's some of advantages that we see. It's based on historical NDVI averages, so you can define a field and then do this analysis from the office, which is very practical, very cost effective. Provides a holistic view of the field. So it's basically it analyzes the crop response. So basically you're summarizing all variables into a single crop activity summary map. So usually the variability methods will focus on one aspect. So electrical conductivity will focus on electrical conductivity. Grid soil samples will do an analysis of each of the individual factors separately. This has the advantage of having a holistic, a comprehensive view of the field, basically. It can be generated remotely with a quick turnaround. With proper analysis and background information, it's not something that you copy and paste or you do it automatically. There's an intelligent operator behind this who is going to be selecting the images, and there's a lot of interaction between that, let's say, imagery analyst and the agronomist. So there's namely Georgina and Francis will be interacting because if an image is chosen on the wrong date, the agronomist, when he validates, and the manager, when they validate the productivity map, will say there's something not quite right. There's something that doesn't really correlate with the field. So then there's an iteration where the productivity map can be adjusted. Usually this may happen in one or two cases, and then for entire region the parameters are adjusted and the productivity map is adjusted. It's a quick, cost-effective starting point for site-specific management. It can be very cost-effective compared to the other methods. It's an ideal tool for correlating in the field. You go with the map and you see what the actual crop performance is, and you start characterizing the zones. You have flexibility in defining the number of classes. If you have a very variable crop, a very variable field, maybe you'll choose 7 classes. If you have a field with less variability, you might choose 3 or 5 to see the differences. And then allows adjusting criteria based on the historic weather context. You're going to select the images according to the weather history as well, so choosing normal years. Or something that we're doing now, it's let's do a productivity map for dry years to see how this performs in drier years based on the weather forecast. Or let's do a productivity map for years which are predominantly wet. So that's also another level of flexibility that you have for your decisions. Again, the limitations, always remember, is this for within fields. Unless you have yield data, you cannot compare fields. And the suitability for annual cycle crops. And finally, we see this as a foundation for more effective farm management. It's been proven extensively in South America and Africa, with initial experiences in the US and East Europe, and Germany as well. The method tends to be improved by local experience. So the more you use it, the more you adjust it, and the more you improve it, and the more it's related with the local limiting factors. It's always interesting to go to a region and see, for instance, in Paraguay, they have issues with pH, and that's a pH and topography are the main limiting factors, and maybe phosphorus. So what they do is they just, instead of doing a complete soil lab test, first they discard the first 2 limiting factors, which is go with a pH meter and also map the topography. So it's always improved by local experience. Then it promotes more sustainable agriculture by optimizing the use of crop input resources, which are more scarce, it's more expensive, so it helps the bottom line, it helps the environment. There are some regions in the world, for instance, the Gulf of Mexico and other in Argentina, we'll see it, maybe in South Africa, we'll see the excess fertilizers, the fertilizers leaching into the water streams are a big environmental issue. It's well known that, for instance, in the Gulf of Mexico, all the excess nutrients that are washed from the agricultural area then create a no-life zone, which is getting bigger every year. So sustainability is very important, and allows to achieve higher yield targets by allowing to reach each zone's full potential, which means uh, maybe an area which it's not profitable to grow. So this, you can identify those areas and just leave it for pasture or for cattle, and then try to reach the higher potential in the areas with higher potential. So it's always allows to optimize from the economic point of view. So for us meaning GeoAgro and users and the partners, the agronomists, the producers who are using these tools, it's been a very let's say a very effective tool, very interesting journey to optimize crop production using this productivity map tool. It works within a framework of a management system where the field visits are important, where the crop season planning, the management decision. It's just a tool that you're going to use within a larger framework of management. So I hope that it's been informative, that it's been useful, and we look forward to working together in testing this tool and validating this tool in your field operations over and over. The next session will be on yield maps, all the very relevant data that you can get from yield monitors. And also based on Francis' suggestion, I think will be very interesting in managing salinity, how we use these different tools. So we'll be sending you the dates and times, always Wednesday, 2 p.m. just for consistency, South African time. And we hope to see you there. And again, thank you very much for joining today. We hope that it was useful, and we look forward to the next session. Thank you very much. Thank you, Francis. Thank you. Bye-bye.